Okay, students, so we are going to continue today. We are going to continue the same lesson, which is basically the wireless communication. We have discussed a number of things about it. So, yes, Moaz, you are raising the hand. Please.
Sir, your voice is not clear.
Okay, let me check.
Sir, yes, now it's clear.
Okay. Yes, Moaz, the voice is clear now.
Yes, sir.
Okay.
Thank you, sir.
Okay, fine, fine. So the thing is that we are actually going through the chapter which is basically about data communication. And you know very well that data communication is basically one of the most important topics in the computer sciences. You know, all these chapters that we have got in our 9, 10 classes or in first year, second years, these chapters are basically the chapters of the computer science that we are studying, just like data communication. These are complete subjects. These are the subjects that you will be studying in detail in the higher classes. But what we are doing over here, we are doing it according to our given syllabus, and we are trying to cover how the question will be asked and in how many ways a question could be written about a particular topic. We are going through this thing. Okay. And we are trying to understand different options over here, in what kind of way the MCQs will be asked, in what kind of way the short questions or the long question will be asked. So this is the thing that we need to understand in this chapter. Still, we haven't done any exercise for the MCQs. I would like to give, inshallah, in the coming week. I would like to upload some MCQs files for you so that you can attempt those tests, and it will these will be normal class tests, not normal class tests, so that you can see what kind of MCQs can be asked and what kind of questions can be asked in the form of MCQs related to these topics. Okay, so this is the thing that we need to understand over here. So we were going through actually the unguided media. This is the topic that we were actually going through. So I would like to continue the same topic today in order to cover all the things as we have discussed already. But we have to understand more about the microwave and the radio wave and the infrared. These are there. Similarly, Bluetooth and satellite is also mentioned. So we have to cover these all things accordingly. Okay, so I'm going to share some videos as well. These are very interesting videos, because normally what happens that when you search a video on the YouTube or any other video streaming platform, so you get a number of videos and you are not able to understand which video is appropriate for me to cover my syllabus, because some videos are there which are in much more detail. Okay, you are not concerned with them and you are not able to grab that knowledge. These are of higher level, and some videos are there which are very, very easy and very simple. Okay, it is not giving us some extra knowledge. These are just animations or just cartoonic explanations or the images. But some videos are there which are quite relevant to our syllabus. So I have found some videos so that you can go through them and you can make a clear concept, because concept is more important in my opinion. When you have got a particular concept, so of course you will be able to write in a better way. As far as the written work or the material is concerned, so definitely I am providing you the material. I am giving you the key points of the in the form of notes to write in your notebooks. I am uploading in your Google Classroom so that your written work should be completed and you may be prepared for your exams in a better way. So this is the thing that we need to understand over here. Okay, so we have seen that the unguided media is basically in the form of waves, and those waves are basically represented in electromagnetic magnetic spectrum. Electromagnetic spectrum is basically a diagrammatic representation of all types of waves which are available for, you know, communication of data, or simple waves which are used for different types of applications. So what are their differences? We have come to know that the waves which are available in electromagnetic spectrum, these waves are basically differing in the wavelength and frequency. So that's why we are calling with the different names, the radio waves, microwaves, infrared, and so on. The difference is basically in their wavelengths and in their frequency. This is the major thing that we understood. So if we come to the radio waves, as we have discussed that, okay, radio waves, these are easy to generate and these can penetrate through the buildings. Okay, these are called the radio waves. And we had discussed the range, the frequency range. Okay, the frequency range is basically from 30 hertz to 300 gigahertz. This is the frequency range. In this frequency, the radio waves lie. And the wavelength may be from 1 mm to 10,000 kilometers, means 1 millimeter to 10,000 kilometers. This is basically the frequency range that is used. Now we discussed that radio waves. We have discussed these all points. Keep in mind in yesterday's class. What I'm going to give you, I'm going to give you a quick review, and then I'm going to share you some important videos so that this concept is should be more clear. So we have discussed that these are used for point-to-point communication links. It is also used in the wireless networks. It is used by the radar systems, and satellite communication also uses the radio waves. We are going to see the satellite as well today. And it is also used for the communication with the spacecrafts. It is also used for the medical purposes, for the different types of, for different types of treatments, medical treatments. Okay. So now what we are going to do, okay, just please pay attention and look at the screen. Then we are going to discuss about it.
We're going to look at radio and we'll see what the different types are and how each of them are used for communication. Radio waves are part of the electromagnetic spectrum and they have the longest wavelength and the lowest frequency of all of the electromagnetic waves. The reason that we call this whole spectrum electromagnetic is that they're made up of oscillating electric and magnetic fields. You don't really need to understand what this means. You just need to know that we can generate them using electricity in the form of an alternating current, because alternating currents are made up of oscillating charges. To do this for radio waves, we use a device called a transmitter, which is normally connected to an oscilloscope. The oscilloscope allows us to see the frequency of the alternating current that we're using, because we can see the frequency of the wave on the screen. And the reason we care so much about the frequency is that it's the frequency of the alternating current that determines the frequency of the wave that we're going to produce.
Okay, up to here, if you see that basically the thing which has been elaborated over here is basically radio waves have got a particular frequency and wavelength, as we have discussed about. All the waves that we are discussing are basically electromagnetic in nature. That's why these are coming in the electromagnetic spectrum. When we say electromagnetic, it means the electro and magnetic, magnetic and electro. So these are the two things which are there, and these are the two types of waves are there which are creating the electromagnetic wave. Oscilloscope, as you can see over here in this video, in this diagram, oscilloscope is basically a device which is used to see the waveform, to see the frequency and the wavelength of the wave. If we attach the oscilloscope with the transmitter and the receiver, so you will see that at the transmission side, the wave format that you are getting will be shown at the receiver side as well, same as it is. There won't be any, particular change in it. You will see that there won't be any particular change in it, and the wave will be transmitted as it is from transmitter to receiver. Okay.
This concept effectively allows us to transfer information. Because, for example, if we wanted to communicate the number 800, we would just generate a wave that has a frequency of 800 hertz. And then anybody with a receiver could interpret it as 800. So we've effectively transferred the number 800 using alternating currents and radio waves. And the cool thing is that we can use this basic method to transfer information of pretty much any kind, not just basic numbers. In fact, the main use of radio waves is for communication, and there are three types that you need to know about: long wave, short wave, and very short wave. Long wave radio waves can be transmitted huge distances, like from London to Singapore, without having to interact with anything along the way. This is because they diffract or bend around the curved surface of the Earth, so they're great for long-range communication. Short-wave radio signals can also travel long distances, but they're not able to curve around the Earth. Instead, they're reflected from the ionosphere, which is an electrically charged layer of the Earth's upper atmosphere. So shortwave radio can also be used to send data over short distances though, like for Bluetooth in your phone. The last type are very short radio waves, which are used for TV and FM radio. And these ones have to travel directly from the transmitter to your receiver, which is why you don't always get a great radio signal when you're in the car.
Okay, so what we have learned over here, even in the radio waves, because you know that the frequency range is from 30 hertz to 300 gigahertz, so there are some categories, just like long waves, short waves, and the very short waves. These are the three categories even in the radio waves. Long waves are there which have the capacity to turn around the earth curvature. Means for example, if you are sending data from one country to another country using the radio waves, so then it is possible the destination is there on some other side of the curvature, so that wave can turn around. But short wave, it does not have this capacity, and this is used for comparatively shorter distances. And over here we have discussed about the very short range. These are basically transmitted directly towards the transmitter to that particular device, just like television or the radio waves. Radio tower is there which is sending us the signal, and our radio is receiving that signal directly. So these are basically the components, basically the three categories which are used in the radio waves. Okay, now I think this thing is very clear to all of you, and we have discussed about different uses of the radio waves. Okay, this is not only used over here; it has a large variety of the uses. Large variety is there, just like radar systems, satellite communication, and other things are there where the radio waves are being used. Now if we go to the microwave, so microwave we had seen yesterday and we have discussed about the microwave जो है, it will move in the line of sight. Line of sight means के it should be in the line of sight. The towers or the antennas should be in the line of sight. This is basically its one characteristic that we must know. And frequency range is 1 gigahertz to 300 gigahertz. So let me share with you one video over here.
A network manager. As a network manager, you've got lots of microwave backhaul links. You have a lot riding on them and a lot invested in them. So when they aren't operating at peak efficiency, you wonder why. Try taking a closer look at your antennas. Imagine you and a friend in the dark messaging each other with flashlights. No problem, right? Now add dozens of people, each doing the same. Suddenly, reading the message meant for you isn't so easy. Microwave links are no different. When multiple antennas are in the same area, transmit signals from some can spill into the receive path of others, particularly where low-cost, non-compliant antennas are deployed. That's side lobe interference. It's a problem, and it's getting worse. Newer radios actually mask interference. In the past, a weak link would be dropped. Instead, weak links are kept in daily operation, occupying bandwidth. You can attempt to mitigate the effects of interference by using a larger antenna, but this increases capital and operational costs. But if you can't reuse the frequency, purchasing more spectrum may be your only option. The greater the interference from excessive side lobes, the higher the chances of an outage. And that means lost revenue and increased cost. A high-quality antenna, fully compliant to regulatory standards, can reduce or eliminate these issues. Using the latest designs of antennas with lowest side lobes, such as those meeting IXC Class 4 standards, bring additional benefits.
Okay, so over here in the beginning you have seen that basically the antennas are there in the line of sight in order to communicate data, communicate the signals. So this problem is now basically, okay, we need to install the antennas in the line of sight, but now this thing is being overcome using some other technologies. So this was the thing that we have discussed. Okay, in a line of sight transmission, the sending and receiving antennas need to be properly aligned with each other. The distance covered by the signal is directly proportional to the height of the antenna, and this is the frequency range. Frequency ranges are very important to remember. What are the uses? It is used for the cell phone communication, and you know that Wi-Fi is also one of the type of the microwaves. Bluetooth is also there. Television broadcast is there, that also uses the microwave. So basically these are the uses which are there in the microwave. If we come to the infrared, infrared is the third type, and its range, what is the range? 300 gigahertz to 400 terahertz, not gigahertz, terahertz. It means these are basically the wave having so much frequency, means the shorter the wavelength. Frequency is high, so it means shorter the wavelength would be. The most common example we have discussed about is that it would have a television, just like a television remote control, but other devices are also there which could use the technology of infrared. So infrared is basically a wave which contains heat energy. Why it is called infra? Because if you will see that in the electromagnetic spectrum, so you will see that it is before red. Visible light may, where we are seeing the red color, so before red the infra is there. So infrared matlab before red. This is an energy type which is containing, this is a type of the wave which is containing energy in the form of heat. and this can transmit data. So over here I am going to share with you one video how it is going to, in the initial part of the video is more important, that is going to elaborate about the working of the remote control, because it is the most common example that we see.
Hello everyone. So if you look at the top of your remote control unit, you will see there is a small plastic LED that is the light emitting diode, which emits the infrared radiation. Now take a look at your TV or DVD receiver. Somewhere on the front there is a small infrared light detector. This detector will convert the infrared light signal into an electric signal. The focus of this video is to explain what goes in the infrared radiation that travels from the remote to your TV. All the buttons that you see in a remote control are connected through an electronic circuit to a microprocessor. So anytime you press a button, the microprocessor will generate a binary signal or a binary code that is associated with that button you pressed. So for example, the code associated with volume up could be something like this. Channel down would be a different set of 1 and 0s, and so forth for all other options in the remote control keypad.
Okay, over here you can see that the remote control is by nature, if you will see that by mechanism, the remote control has got a digital circuitry in it. A chip is there which is basically interpreting the purpose of all the keys which are available on the remote control. Just like 1, 2, 3 are the numbers of the channel. Similarly, we are increasing the channel numbers or decreasing the channel numbers or volume and applying different options on and off and such options. So every key has got a particular purpose. So when you will press the key, so how would the remote will be able to know? Okay, it will convert basically that key's purpose into a digital signal that would be in the form of zeros and ones, and that zeros and ones basically will be transmitted, but by converting it into the infrared.
All the binary command codes will have the same number of bits. In this example, it is 6 bits. As you see here, bit 0 corresponds to low voltage, while bit 1 is the high voltage. And this takes the full duration of the bit. In reality, the binary code that is transmitted is slightly different than the simple binary code I presented here. Bit 0 is represented by high voltage in the first half of the bit duration, followed by low voltage. Indication done on the binary code before it gets transmitted is to modulate the binary code with a 36 kilohertz signal, that is the frequency carrier you see here. So instead of having high level voltage, you have a train of pulses at 36 kilohertz. So why the binary code is being modulated? Well, because some light include infrared light that can interfere with the binary code. So modulation makes the infrared light signal becomes.
Okay, so over here, the thing that you need to understand is that that particular binary code need to be modulated in the form of a wave, and that wave will be passed to the television using remote
Now,
control.
in addition to controlling TV, you may want to control other devices such as TV box, a DVD player, and probably a PlayStation. In order to do that, the IR signal needs to also indicate which system the command is intended to. So beside the command control, the IR signal include an address code that specify the device to control.
Okay. So for different type of devices, we have got remote controls to send signal to that particular device, and definitely afterwards we were having the much more details about the address code of particular device. So we are not going in that much detail, but over here the most important thing is that the transmitter will be the remote, and there would be a sensor which is receiving at the receiver's end, which is receiving that particular signal. This is the most important thing. Now if we go to the Bluetooth, so Bluetooth में हमने क्या कहा था कि Bluetooth is basically a wireless technology used for exchanging information, data files for short distances, and frequency range is 2.402 to 2.480, and you can make a PAN, personal area network, using a Bluetooth network. You know very well that this is also a technology that you would have used. This is not anything that you don't know, but let me show you one video so that you can understand the concept in with much more elaboration. Okay.
Going to get more complex as we keep moving. When we say Bluetooth, we really mean the connectivity between devices because this involves both a signal and some hardware. On the hardware side, both devices need to be equipped with an antenna-supplied chip that can encode, decode, and transmit data via an antenna. We all have probably tried and hopefully succeeded at connecting a device through, usually the one with the final output, like a speaker, sends out pinging signals that can be detected by other Bluetooth-enabled devices. In other words, it shows up on your phone screen. Once you hit connect and link the devices together, you've just formed a PicoNet. No, this isn't a net used to catch yellow Pokemon. Pikachu net. Okay. This is actually a micro-network of recognizable radio waves communicating back and forth between devices. These waves are short, about 15 meters, so that there aren't conflicting Bluetooth waves all over the place. The signal itself operates within a frequency of 2.4 to 2.485 gigahertz, which falls in the unlicensed scientific, industrial, and medical category. To continue down the path to technical understanding, according to Bread spectrum frequency hopping full duplex signal at a nominal rate of 1600 hops per second. To break that down into words that just about every frequencies, a lot, about 1600 times per second.
Okay, so what actually we are doing when we are using the Bluetooth, we are making a personal area network by attaching multiple types of devices. Okay, before going towards the satellite, let me mark for the attendance. Okay. So we have discussed that the Bluetooth is used for transferring files between the devices, play multimedia, player games over Bluetooth, and similarly we can control different home appliances using Bluetooth technology. Similarly, we can attach peripheral devices, just like this is the most common use: mouse, keyboard, headphones. These could be connected using Bluetooth. So this is the thing that we have discussed already in yesterday's lesson. I'm going to share with you some just demonstrations in the form of videos so that the concept could be much more clear. Now we move towards the satellite communication. Okay.
Satellite communication. A satellite is an artificial body placed in an orbit around the Earth or another planet. The communication satellites relay around the world telephone and fax messages, television programs, radio signals, and so on.
principle of satellite communication. The process of communication begins at an Earth station. The Earth station is an installation designed to transmit and receive signals from a satellite in orbit around the Earth. Earth stations send information in the form of high-powered, high-frequency signals to satellites that receive and retransmit the signals back to Earth. These retransmitted signals are then received by other Earth stations in the coverage area of the satellite. The area which receives the signal from the satellite is known as the satellite's footprint. The transmission system from the Earth station to the satellite is called the uplink.
Okay, so over here you can see that number one thing is satellite is moving around the Earth. It is used for the data communication. Of course, it would be connected with some base station or also called Earth station. Earth station would be there on the Earth, of course, which would be connected with the satellite. The Earth station would be sending the signal to the satellite, and satellite would be sending the signal to other base stations or other Earth stations, the receivers. And that particular area which is covered by a particular satellite is called the satellite's footprint. Means that area where it is providing its services. When we are sending data from the base station to the satellite, this is called uplink, and we are receiving data from the satellite to a base station is called downlink. Okay.
And the transmission system from the satellite to the Earth station is called the downlink. Here you have the schematic representation of the principle of satellite communication. To avoid confusion, the uplink and downlink frequencies are kept different. Before designing a satellite communication system, we must choose the orbit in which the satellite is to be placed. Orbits are of three types, namely geostationary orbit or geosynchronous orbit, polar circular orbit, and inclined highly elliptical orbit. Geostationary or geosynchronous orbit. In this type of orbit, the satellite takes 24 hours to circle once around the Earth. Since the period of revolution of the satellite is equal to the period of rotation of the Earth, the satellite appears to be stationary in the sky. For this reason, this 35,900 kilometers high equatorial orbit is called a geostationary orbit. The geostationary.
So afterwards, they are explaining about the types of the orbits. Definitely, we are not going to discuss them in detail, but one important point that I would like to tell, okay, when the satellite is moving according to the movement of the Earth around its orbit, this is called geostationary satellite. So that particular satellite will retain at some particular country. For example, if Pakistan satellite is there, so it is geostationary in nature. Why? Because it is moving according to the movement of the Earth around its orbit. So that's why it would be a geostationary satellite. As we have discussed, that satellite may be for different purposes: televisions, transmission, telephone transmission, navigations of the different areas, maps, and etc. There is a possibility for your business and finance different purposes you are using the satellite communication. Weather condition, this is most important. These are being used for the weather conditions, to know the weather conditions. Similarly, climate and environmental changes. If you talk about the space, so of course the satellites are there which are serving for us regarding the knowledge of space. They are bringing the knowledge about different planets and about different, by taking the pictures of the planets and the galaxies. So these are basically different ways, okay, different areas where the satellites are basically serving the humanities. And these all are the areas. But for data communication, we can see that all satellites are basically sending or receiving data. But the purpose may be some different purpose. Some weather satellite is there, so if it is just restricted to the weather, and if some television satellite is there, so definitely it is receiving and sending the uh, frequencies of the television channels around the globe, and these are basically the devices which are receiving and sending those signals. So these are different areas where the satellites are serving us. So I think, okay, up to here all the things would be clear to all of you, and you would be able to do. I will upload this remaining material for the Bluetooth and satellite in your Google Classroom, so that you can download it and you can write it down in your notebooks. Keep in mind that your notebooks should be complete. Notebooks should be complete regarding all aspects. The work which is being given to you